In this video we're going to solve quadratics by taking square roots. I'm going to begin with a very basic example so that we can wrap our head around what's going on when we solve a quadratic by taking square roots. And that example is x squared equal to 4. So I'm asking what number, when multiplied to itself, gives me a product of 4. And a lot of students automatically just think, alright, x equals 2. And you would be completely correct in thinking that because 2 times 2 equals 4. However, that is not the only correct solution. If I let x equal negative 2, this will also work because when you multiply negative 2 to itself, you also get the correct product of 4. So you actually get two solutions for the quadratic if x squared equals 4. Now, when we actually solve by taking square roots, let's use the same example and see what it looks like in practice. If I have a number and I'm squaring it, and I want to undo squaring to get x by itself, the inverse operation is square rooting. So I could square root both sides of the equation, much like if I had x plus 2 equals something, I can subtract 2 from both sides to undo adding 2. In this case, the square root of x squared is x, and the square root of 4. Now remember, the answer to this problem had two solutions, 2 and negative 2. So to take care of that, we have to take plus or minus the square root of 4. That really means, if I simplify the square root of 4, my answer is x equals plus or minus 2. Now this is the first time we've really seen this notation. That plus minus sign is read plus or minus. So it really means there are two answers here, 2 or negative 2. But it's just kind of a nice condensed way of writing the solution. We can use 2 or negative 2 to satisfy this equation. So in general, if we were trying to solve x squared equal to a, and we were solving by taking square roots, I would have to get x equal to plus or minus the square root of a. A lot of students forget the plus or minus. Please don't be one of them. You'll probably get a point or two off in your problem on a quiz or a test. Let's do example 1 together, which is more the speed of what you'd see in a homework or a quiz. If I have 2x squared plus 1 equal to 17, and I want to solve this thing by taking square roots, your first objective, and it's a good idea to have these steps in mind, the first objective you have is to isolate, or get by itself, isolate the squared term. Alright, so the squared term in this particular example is x squared. That's the only thing that's being squared. So I'm going to try to get x squared equals. So I'm going to treat this the same as if it were 2x plus 1 equal to 17 and subtract 1 first from both sides, undoing the adding 1 on the left, leaving a 2x squared alone on the left side, and 17 minus 1 is 16 for the right. Now I still need to get the x squared by itself, and since it's being multiplied by 2, I'm going to divide both sides by 2. Now I have just x squared equal to 8. And now I'm ready for my second step, because my first step I have accomplished isolating the square term. Now I get to take square roots of both sides. By the way, I have a funny saying that I like to do so I don't have to write out take square roots every time. I just call this TSR for short, and I'm kind of goofy and I like to call this my taser just to make it a little bit more fun because it's like TSR for short. So taking square roots, TSR, taser, both sides, but you gotta remember your plus or minus sign. Very, very important. So when I take square roots, or taser, I get x equals plus or minus the square root of 8. Now we're not quite done with this yet. We could be in some problems, but let's just double check. Third step is to simplify the radical. Alright, now if you're going to simplify the radical, we're doing essentially what we did in the last lesson. So I have to break 8 down into the product of any perfect squares if I can, and I know 8 is the same as 4 times 2, and I'm going to stop there because I know 4 is a perfect square, so I can rewrite this as x equals plus or minus the square root of 4 times the square root of 2, or just plus or minus 2 square root 2 as my final answer. Now remember, there are two answers there, one of which is 2 radical 2, and the other is the opposite of 2 radical 2, or negative 2 radical 2. You can write them either way. I'm going to be happy. Just make sure you don't forget the plus or minus sign, or make sure you write them separately and you'll be okay. Let's do another example on another slide here. Okay, example 2. In this slide, let's try to solve the following by taking square roots. Let's do 1/3 of the quantity x plus 5 squared, and that's equal to 7. Alright, so our first objective, much as it was on that last example, the first thing that we're going to do is isolate the squared term. Alright, so in this particular problem, the squared term is the binomial x plus 5. If I'm going to isolate that, I have to get rid of the multiplication by 1/3. Now I know a lot of you like to divide by a fraction. I don't, because it's going to make things more complicated in the long run, especially when we get to rational functions later on in the year. Instead of dividing by a fraction, you should get used to multiplying by the reciprocal, which would just be the number 3. So I'm going to multiply 3 to both sides, which is going to be a lot nicer looking. 3 times a third cancel to make 1, leaving just behind the x plus 5 squared on the left, and 7 times 3 I know is 21. I've accomplished the first goal, or the first step of isolating the squared term just by multiplying by 3. Now I'm ready for my second step of taking square roots, right? So I'm going to square root this entire side, and I'm going to square root this entire side. The square root and the square undo each other. I'm left with an x plus 5 on the left, and plus or minus the square root of 21 on the right. Now if I can, I would try to simplify the square root of 21, but I think you're not going to be able to, because it's just the product of 7 and 3, and there are no perfect square factors there. My last step, though, is to still get x by itself. I don't want to know what x plus 5 equals. I want to know what x equals. So I have to subtract the number 5 from both sides of the equation. If I do, these will cancel, giving just x equals. Now, I cannot somehow combine negative 5 and the square root of 21 together. I have to write it like this. I have to do negative 5 plus or minus the square root of 21. Now, you can leave your answer like that. However, if I wanted the approximate value of the solutions, you'd have to type the following into your calculator. And there's two answers here, remember. There's negative 5 plus the square root of 21, or there's negative 5 minus the square root of 21. So if you had your calculator and we had to do this, I would do negative 5, well, how about turn this thing on? So I would have to do negative 5 plus the square root of 21 and see what that's equal to. I'd get about negative, 0.42, and negative 5 minus the square root of 21, and I'd get that value. So if I had to write another possible solution here, I can also say x is approximately negative 0.42 or negative 9.58. Now remember, this was really negative 5 plus the radical 21, and this guy is negative 5 minus radical 21. Alright, just so you know how to do that. Let's do an application of taking square roots to solve a problem next. Okay, so you might hear my baby going "I got" in the background on this one. It's kind of cool. Anyway, we're going to model a falling object using a quadratic function. So please write this down for me. You will apply this in a quiz or a test. So we can model falling objects with the following equation. H equals negative 16 t squared plus h naught. Let me talk about what these different things are in the equation. H is the height of an object in feet, t seconds after falling. Okay, so clearly t is the number of seconds the object has been falling. And this guy right here, h naught, it's pronounced h naught, is just the beginning height. This is the initial or starting height. I should write just initial height. And again, this has to be in feet. Now, this only works on planet Earth because we're taking into account acceleration due to gravity with this constant, negative 16, and it also neglects air resistance, so it can't model perfectly every falling object, but it gives you a good idea. Let's apply this in an example next. Let's call this one example 3. How long does it take? Let's go like this. How long does it take a stuntman, not a stud man, let's do a stunt man, to hit the ground from 100 feet up in the air, 100 feet in the air. So let's assume first of all that he's not going to hit the ground, right? He's going to crash on a mat safely, and everybody's happy. And he's up like 100 feet on some kind of like, you know, building or something like that for a movie. And they need to know how long he's going to be in the air to maybe choreograph some other good stuff going on in the movie. All right. So what the smart person in the crew might do is use the following equation to figure this out. We have the formula h equals negative 16 t squared plus h naught. Now, we know the starting height is 100 feet, so we know what h naught is. That's going to be 100. We are trying to find what the time is going to be, so I'm just going to leave negative 16t squared alone and add it to 100. However, I do know what h should be, or what I want it to be. You can also think of h as being your final height, if you will. I want this, let's write that. This could be your final height. If I want the stuntman to reach the ground and we have to assume then your height above the ground is 0 at that point. So if you're hitting the ground, your final height or your h value should be 0. And we just have to solve this equation for t. Well, let's apply what we know about the solving by taking square roots. I have to isolate the squared term first, so I got to get this guy by itself. I'm going to subtract 100 from both sides, leaving negative 100 equals negative 16 t squared. I still need to get the t squared by itself, so I have to divide everything by negative 16. If we do that, I have a negative divided by a negative, really making a positive 100 over 16 equal to t squared. Let me go over here for some more room. If I have 100 over 16 equal t squared, let me write that. I have the same thing as t squared equals 100 over 16. I'm ready for taking square roots. I would square root this side and square root that side, giving me just t equals. Now it's plus or minus the square root of 100 over the square root of 16. Hopefully you remember what property that was. What was that? The quotient property, right? And these happen to be beautiful numbers. The square root of 100 is just 10. The square root of 16 is just 4. So 10 divided by 4, what is that? Reduced to 5, cut in half. That's 2.5. And the units for this are seconds. Now, somewhere along the way, I kind of forgot the plus or minus sign. So technically speaking, my answer is plus or minus 2.5 seconds. All right. The negative one doesn't make any sense in this application because if the director says go and the stuntman jumps, it's going to take a positive 2.5 seconds for this guy to hit the ground. We're not going to be in science fiction land where it's like negative time 2.5 seconds going in reverse or something like that. So for this application, the negative solution could be thrown out. The answer is just going to be your 2.5 seconds. Kind of a cool application of quadratics. Hope you liked the video.